Hi, Year 11. This is Mr. Seo. So now this, as I promised, this is the second video for the distance learning. And like I said before, and this is now the development part of 4A. So starting with question 8, you're given, in part C, you're given the function there. That's the benchmark function, y equals x cubed. And you have to move it now by 1 unit to the left. Okay, so this is the left. So anything with the right or left movement, that's got to do with the x. So you can think of that as x equals -1 because it's left. So to the left, so it's -1. So if you make that side right hand side 0, that means x plus 1. So what that means is instead of x, you now have to use x plus 1 here for that new function. So instead of x, we're using x plus 1. So that's this. Okay, now graphically what that means is, remember y equals x cubed, it's sketching like that. Okay, so, and you basically have to push that one to the left by 1 unit. So you know that what used to be the y-axis is now x equals -1. So that's what we call the point of inflection. So that's that. Remember, we're not twisting or contracting or stretching any of these. So all you're doing is pushing it, okay, to the side or up or down, okay. So that's the new graph. And notice it cuts the the y-axis at 1. How do I know that? Well, in the new equation, you put x equals 0. Okay, so then you'll see that 1 cubed is still 1. So that as a side note. Okay, so part G. So you're given this original curve as xy equals 1. And notice that if you rewrite that, making y the subject, you get y equals 1 on x. So we know that because this 1, okay, so that 1 is a positive. So we know from theory that it takes up the first and the third quadrant of the number plane, making the x-axis and the y-axis as the asymptotes. Okay, so now in terms of the transformation of the translation, we're doing down by 1 unit. So this is now down, so it's up or down movement. So it associates with the y value. So you can think of that as y equals -1 because it's down. If it's up by 1 unit, then it will be plus y equals +1. So then y equals -1. So move the -1 over to the other side. So that's y plus 1. So that means instead of y, you're now replacing y plus 1 into that original function. So then you get that. Okay, so to sketch the new one, it'll be pushing it down by 1 unit. So you notice the the y-axis is staying the same, but the x-axis is now gets pushed down by 1 unit. So you get y equals -1 as one of the asymptotes. So the new asymptote. So y-axis and y equals -1 as the new asymptotes. So that's the what used to be the third quadrant. It's still in this third quadrant, but down a bit more. And this, the green part, is now, as you can see, is cutting through the x-axis at 1. Again, you put, to work that out, you put y equals 0, so it's x equals 1. So 0 plus 1 is 1. So x times 1 equals 1. So therefore, x has to be 1. Okay. Now, if you're interested in algebra side of it, to make y the subject, all you got to do is, that's the new equation, remember, that's there. So first of all, have to make y plus 1 the subject. So then you get that, divide everything by x, then you get this. And therefore, finally, you have to move the plus 1 over to the other side, then you get that. Okay. All right. So that's the first question. And the next one is question 9. Okay. Now with this question, you're not given, notice that you're not given the equation for it, but you're given the sketch of each of these two functions on the next page, which looks like that. Okay, the black one for the first one and black one for the second one for gx. So bearing that in mind, all right. So what does that mean though? P bracket x plus 1. So, well, as before, you look for the x value that makes this whole thing 0. So that means x equals -1. Hence, it's x. So therefore, it's either right or to the left movement. So because it's negative, you can say that, okay, so it's 1 unit, you're moving the 1 unit to the left. Okay, so left here and 1 unit to the left. So that's important to note. Okay, 1 unit to the left of the origin. All right, so then given that black curve as y equals px, then the new one, remember all you got to do is you push that one to the left by 1 unit. Now, for you to do that, the first step that I would do is I would actually come up with all the important points. So for example, this one is quite easily, quite readily read off. So it's negative 2 comma 1, negative 1 comma 1, 0 comma 2, 1 comma 1, and 2 comma 2. So it's all given. So make those noticeable so that you can track. All you got to do then is now move that one to the left by 1 unit, move that one to the left by 1 unit, and so on. Then you can generate all these green points, okay, by moving each of these 5 points to the left by 1 unit. So then all you got to do is now to connect all these, bearing in mind, remember this is all translation. So you're not squashing or squeezing or contracting or stretching any of these parts of the curve. So all you do is shifting. So try to carefully, basically retrace the original curve. Okay, so then you get the green one as the new curve. Okay, all right, now part D. So that's the given curve. Y minus 1 equals gx. You can't do anything on this one. So now you have to fiddle around with this. Now think of the y value that makes the left-hand side 0. So that's y equals 1. Or you can think of it this way. Because that negative 1 is a constant, toss that over to the other side and you get this. And because it's a constant as plus 1, remember that all you got to do is whether you look at it this way or that way, anything associates with the y, or you look at it as a constant, it's just dragging up or down by that unit. Because it's plus here, it's moving up or dragging up by 1 unit. So 1 unit up. Okay, that's an important thing to note. All right, so the black curve is sort of the semicircle and then 2 straight lines coming off from negative 1 comma 0 and 1 comma 0. Then all you got to do is remember you have to shift that one or push that one up by 1 unit. So again, as before, label all these important points that you can quite easily read off. So that's these 3 points, and push it up by 1 unit and click that. Push it up by 1 unit and you click that, and same. And remembering trying to trace the original curve like that, and that straight line and that straight line. Now remember these 2 straight lines, because we're not doing any twisting or squashing or anything like that, these 2 have to be parallel to each other. Same with these 2. Okay, so that's now the new curve. All right, next one. Question 10. So you're given the parabola with the vertex at 0, 0. Basically, that means y equals ax squared, where a is not 0, obviously. Now, if you have a look at the given curve, the leading coefficient is 1. So what you're comparing that with is this y equals x squared, where a is 1. Okay, so you need to explain this in terms of that, in the language of the transformation. And here, all you got to do is to put that into the perfect square form. Okay, so then there's this. All right, so remember when you do the perfect squaring, you forget the constant for the time being. So just worry about the first 2, the quadratic and the linear term, and halve the value in front, sitting in front of the x. So here, half of negative 2 is negative 1, and you put that as a square form. Okay, but when you expand it out, then you get this. Again, if you're not familiar, I'm using this binomial product formula. Okay, so that gets you this, but I had to have negative 2 at the end to make it equal. So I have plus 1, hence I need to subtract the 3 to get back to minus 2, because plus 1 minus 3 is minus 2. So that's that one. Now, let's now think of this. So there are 2 things going on here. Okay, so what I'm going to do is take the negative 3 over to the other side like this. So then I look for the y value that makes the left-hand side 0, and also at the same time, look for the x value that makes the bracket 0. So then you get that, all right, and that. So y is a -3. So remember, anything associates with y, meaning moving up or down. Because it's negative, down by 3 units. So here we go, 3 units down. And x equals 1. That's a positive value. So anything associated with x is either right or left movement. So it's positive, so it's to the right by 1 unit. So there you go, 1 unit to the right. So that's all you got to remember. Now, that means your new vertex is now 1 comma -3. So what used to be the 0 0 is now, because you're moving 1 to the right, so it's going to be +1, and 3 units down, so -3. And also, you know from the perfect square knowledge, completing the square knowledge, that any x value that makes the whole thing 0 and y value that makes this thing 0 will give you the vertex coordinates, the coordinates for the new vertex. Okay. All right, so that's y equals x squared, and according to this, in the language of translation or transformation, that's 1 unit to the right and 3 units down. So that's that. Okay. Now, look, I had a scaling problem here. It looks like it's completely, it's not symmetrical, but it's meant to be symmetrical. So when you draw it, make sure you be careful with your scaling. So, and again, I want to emphasize that this here, the the shape needs to be preserved. So in other words, you can't have the new graph being stretched like the way that I did. So it's meant to be symmetrical around this. X equals 1 as the new axis of symmetry, and it should be, it's about this thickness there. Okay, so hopefully you get the point. Okay, so, and the second last page, that's section F. So that's y equals half x squared minus x minus 2. Because of this half there, we're now comparing that with half x squared. All right, so again, the perfect square. So you force the half as if it's a common factor, even if it's not. So then you get this, and notice I'm leaving the constant as -2. And the next line is I'm now trying to express this as a perfect square form. So half of -2 is -1, so that's that. But when you expand it out, then you get x squared minus 2x plus 1. But I never had the constant. Okay, I'm talking about when I say constant within the bracket, okay? So that's minus 2x and stops, meaning that's plus 0. But I have plus 1, so I have to subtract the 1 from it so that it's 1 minus 1 is 0. Okay, so that's that. And therefore, for the next line, I'm expanding half by half with this and half with the -1 to get the second this line here. Okay, and putting those two, minus half and minus 2, then you get -5 on 2. Okay, so again, the same sort of deal. Move that one with the constant over to the other side and bundle it up with the y, and you look for the y value that makes the whole thing, the left-hand side 0, and also the x value that makes the bracket 0. Then you get that and that. Hence, it's negative for the y, so it's moving down by 5 on 2 units, or 2.5 units down. And because that's x and positive value, so it's moved to the right by 1 unit. So that's that. So the new vertex is 1 comma -5 on 2, or -2.5. So when you draw it, so 1 unit to the right and 2.5 units down. So that's the new vertex. Okay, and that's the new curve. All right. Okay, now the last one is going to do with the circle whose center is now off the origin. So that's that one. So all you got to do is you perform the perfect square, or completing the square business, on those two terms and those two terms. Okay, so x and y basically. So notice I put the brackets there with the x's and y's. All right, so half of +4, 14 is +7. But when you expand it out, then you get x squared plus 14, x plus 49. Okay, and therefore, notice I have the 14 as a carried over instead of trying to kill it. So if you expand it out, then you get plus 49. But I never had any constant other than 14 within the bracket. So, 14 is already there, so I don't need to worry about it. So you need to make it 0. So that means subtract the same amount by 49. And same sort of deal going on here. When you expand y minus 1 squared, it's y squared minus 2y plus 1. So to make it equal to 0, because there's no constants there, you have to subtract the same amount with the 1. So that it's 1 minus 1 is 0. Then you get that. And now collect the constants, 3 constants together, then you get minus 9, 36. Move it over, then you get 36. Okay, and that's 6 squared. All right, so that means the new center, remember the x value that makes the first bracket 0, and y value that makes the second bracket 0. It's negative 7, 1. So that's now the new center, and the radius is the square root of 36, the positive square root of 36, I should say, and that's 6. All right. All right, so that about does it for this development part of 4A, and then the next video will be obviously on 4B. All right, see you guys next time.